Hearing, special senses hearing. Ear.
We have an outer ear, a middle ear, and an inner ear. All the action in terms of the physiology occurs in the inner ear. So we take our environmental stimulus in terms of hearing, which is not a light source, but rather it's a sound wave that comes into the outside inner ear and gets converted to, at some point along the pathway, gets converted to, just as we saw with the photoreceptors in the retina, convert the light source to an action potential depolarization wave with neurons. We're going to see the same thing occur with the sound wave that ultimately gets transferred into an action potential with neurons in the inner ear that will facilitate the neuronal impulse going back to not the occipital lobe, but rather the temporal lobe on the sides of the head where we have our hearing perception area. So we have three structures, three major structures, or three categories of anatomy when we talk about the ear. The outer ear, which includes the pinna, that's the flappy part of your cartilage of your ear here, includes the external auditory meatus. That's the canal that leads from the pinna that goes into the inner ear and ends with a structure called the tympanic membrane. Known to people who don't take anatomy classes like we do as the eardrum. So now when someone refers to the eardrum, you'll know that it's the correct terminology, anatomical vocabulary, anatomical nomenclature, this is tympanic membrane. So we always use our anatomical nomenclature and our anatomical vocabulary when we're speaking in class. The inner ear is composed of a group of bones called the ossicles. And the ossicles are composed of the malleus, the incus, and the stapes. And these are nothing but three very small bones located on the other side of the tympanic membrane. And they don't convert any sound wave into action potential, but they facilitate the process with which the sound wave makes its way back into the inner ear. And the sound wave is actually converted, once it does get to the tympanic membrane, is converted to a vibration. It's converted to a vibration, and then ultimately in the inner ear is converted into an action potential. The inner ear is where the action is, and the inner ear is composed of three structures, two of which are helpful in equilibrium, and one is really involved in hearing. And they are the cochlea, the vestibula, and the semicircular canals. Cochlea, cochlea is responsible for hearing, or helps in hearing, facilitates the action potential of hearing, and the vestibula and the semicircular canals are involved in the process of the equilibrium. Okay. So the function of the pinna, the cartilaginous area of the ear, is really acts as a kind of a funnel. So sound waves that come in to the ear are kind of funneled down so that they can enter into the external auditory meatus, or our ear canal. Okay? At the end of the ear canal, as we in the ear canal is really a hole in the temporal bone of the skull. A hole in the temporal bone as that makes its way in there. As the sound wave goes into the external auditory meatus in the ear canal, it then hits on the tympanic membrane. or the eardrum. And the sound wave, when it hits on the tympanic membrane, is converted into a vibration. It vibrates the tympanic membrane. And the tympanic membrane ultimately leads directly into the middle ear in the ossicles. And that vibration on the tympanic membrane will rattle and vibrate the bones of the ossicles. First the malleus, then the incus, and then the stapes. And if we look at the model of the middle ear, this is the area here that abuts the tympanic membrane. This is the malleus. The second bone here is the incus, and this final one here is the stapes. This part of the stapes here, which is the closest to the inner ear, this is the third ossicle, this part of the stapes is called the oval window. And the oval window on the part of the stapes literally connects to the internal part of the inner ear. So that's the passageway from the middle ear into the inner ear. So really, there's nothing really too much happening in the ossicles other than the eardrum that takes that sound wave. If we look at a larger model of our ear here, even though these things are small, you can see the ossicles here on the back of the tympanic membrane. So this is obviously the outer ear, the pinna here. This funnels down sound waves into the external auditory meatus, comes back and hits the eardrum, and you can see how the malleus is located on the back of the tympanic membrane. So once the sound wave hits the membrane, it rattles the malleus, and as the malleus starts to vibrate, it then vibrates the incus, which is the second ossicle, and the incus vibrates the stapes, which is this third little piece here, this little model. And I don't like this model too much because it separates the ossicles which are part of the middle ear, from the inner ear, which is the semicircular canals here, the vestibula, and this is the cochlea. So this is your inner ear, so it does separate them, but they connect like this. And this is a smaller model of the larger model that I just showed you on those ossicles. So really all we're doing in the middle ear is carrying that vibration from the eardrum or the tympanic membrane back to the inner ear through the vibration or the rattling of the malleus first, then the incus, and then the stapes, which connects to the internal part of the ear. And we'll use these models tonight to take a look at those particular structures. So far, what have we done on our? We've taken a sound wave. We've taken that in through the pinna, through the external auditory meatus. Now we've bounced that off the tympanic membrane. Right, we've gone into the middle ear, and for those of you who have young children, you've heard of the term middle ear infection. That's where the kids get the earaches all the time. They get infected. You put the drops in the ear, and you go to the middle ear. You have, as opposed to a much more serious inner ear infection, which would be in this deeper area of the ear. This is a fairly common middle ear infection. So the tympanic membrane would be 4. We go back into the ossicles in terms of the malleus, incus, and stapes. So that would be 5, 6, and 7. Okay, so when we leave the stapes, we articulate through the oval window with the stapes to the inner ear. And let's talk about hearing, since that's the most involved pathway. Let's look at, once we get that vibration back to the inner ear, that sound wave is going to take effect in the cochlea. And let's look at the cochlear structure. It's very important to understand that and understand some of the really small or micro anatomy to understand how we then convert that rattling, now vibration, really, so the sound wave has been converted now into a vibration here. So we vibrate the tympanic membrane, and that vibrates the incus, the malleus, incus, and stapes. And that vibration goes back into the cochlea. And the cochlea looks a little bit like a snail that you find on a beach. And then it has a 2.5 revolution area, and it has within itself, it has a what we call an area here inside. So this structure is a bone, cochlea is a bone, and it's really what we call a bony labyrinth, L-A-B-Y-R-I-N-T-H, a bony labyrinth. Within the bony labyrinth of the cochlea, which is 2.5 revolutions around, the black lines represent the bone. Within this bony labyrinth is the blue area here, which follows the contours of the bony labyrinth, which is the 2.5 revolution circular structure. But this blue area here is called the membranous labyrinth. So this is a membrane, not a bone, within the bony labyrinth. So if you take a hardened structure with 2.5 revolutions around it, and within that hardened structure, you put a membrane, a softer structure within the membrane.
So blue is the bone,
So
right?
the outside here, this would be the bony labyrinth. And inside here, this is called the membranous labyrinth. Because this is formed with a membrane, a very, a soft tissue membrane, and this is with hard bone. Okay, so the membranous labyrinth literally follows the contour of the bony labyrinth. So you have this 2.5 revolution circle structure of bone, that's the cochlea, and within that contour of the 2.5 revolution circles, you have a 2.5 revolution circle of membrane called the membranous labyrinth. And there is fluid in both of these. The fluid in the internal membranous labyrinth is much thicker, and this fluid is called endolymph. Endolymph, a much thicker fluid. There's a thinner kind of not as thick type of fluid found in the bony labyrinth, which is called perilymph. So endolymph is found in the membranous labyrinth, and perilymph is found in these areas here. Okay. Now, this area here, this membranous labyrinth, is also referred to as what we call the cochlear duct. And it is in the areas of the cochlear duct where we find smaller structures that lie on the basilar membrane. In this part of the cochlear duct here, that runs underneath the endolymph, this is called the basilar membrane.
So what's cochlear duct again, and where is it found?
The cochlear duct is the same thing as the membranous labyrinth. Okay, so you have a 2.5 revolution bony structure. Okay, within that 2.5 revolution bony structure, you have an identical 2.5 revolution membranous structure, bounded by a membrane. Within that membranous structure, 2.5 revolutions, you have a very thick fluid called endolymph. Within the 2.5 revolutions around the bony structure, you have a very not so thick fluid called perilymph. Okay, so the perilymph is found on top of and below the bony labyrinth. Remember, this is one revolution here of the bony labyrinth, right? And within the bony labyrinth, you have the membranous labyrinth that follows